I will start my talk. We're gonna talk a little bit of the share state cache, how to use it, and how to optimize it. So this is my talk. So reducing Yocto build time through share state cache optimization. Before I dive in the agenda today, I'm gonna present myself. So I'm a software engineer and consultant with 10 years of experience with embedded Linux and Yocto. I work at EMC Logic, handling software development, consulting, and training. MC Logic is a Brazilian company with 6 years in presence in the market. We provide consulting, training, and software development for microcontrollers and microprocessors and embedded systems. My contacts are on the slides. You can shoot me an email if you want. And talk about the presentation and other topics. So for the today agenda, we're gonna before we dive in to talk about the cache, the state cache, we're gonna do some background on daily use of Yocto. I think everybody here use it daily, but gonna take like an example just make some cases that we're gonna see forward in the presentation. Then I'm gonna talk a little bit about the state cache and the hash equivalent server, the two parts of the open embedded system that helps us with the caching mechanism. And then we're gonna show two possible setups, one locally and another one locally in the machine that you are building your projects. And another example, we're gonna share our cache through an HPP server on a private network. And we're gonna see some results and what we can reduce our build time doing this. And then to sum up our talk, we're gonna talk about some strategies, how to keep our state cache updated, and address some common issues. Okay. And in the end, if someone has something to complement, is more than welcome. Okay. So starting off, let's talk about our daily use of Yocto. I think everybody here is more than do this a lot of times. Just to recap. So when you use Yocto, what you're basically writing script, creating recipes, building this recipe and testing them. You're creating BB appends, validating package configuration, tweaking configuration, managing lane organization, creating new distros or machines, and finally building images and testing these images either by QEMU or in the final target. All of those activities with the building process take time. So if you have a machine with more resources, you're gonna have lesser build time, and you will finish your assignment faster. But all the tasks here so for each build, you're gonna increment your time to let's say to conclude your task, your final image or project. Okay, so build time is very critical for the time of your project and the success of your project. So another thing to keep in consideration is a common scenario. I'm in Brazil, but I think this happens in other countries as well. Normally people, especially people that are coming in to work with Yocto Project, they're not very is the first contact of Yocto, is a new project. Maybe in some companies, maybe they're working with commodity hardwares. So laptops, they're not very suitable for a Yocto build. So this is very common. You see people struggling on the first build, and the first build takes time. And this is very common that we have machines that are not very suitable for Yocto. But as we're gonna see in the slides, this can can be solved and we can find a workaround for that. So we can use the shared state cache to decrease the build times, and also share it, the state cache, to others' machine to decrease build time. So the solution that the Open Embedded and Yocto community provides off the shelf is the state cache and the hash equivalent server. The two of those, they can be shared across. If you have on a local machine, you can share this cache locally to different build folders, different projects that you're working on, and you can share it through network to other machines, which is a good part. We're gonna see this, and also we can share the downloads folders. Everything that we download, we can share it to reduce build time. Talking a little bit about the state cache, the shared state cache. I'm not going too deep on the inners of the state cache or even the hash server, but just to give an idea who is coming in with just to clear this out. So by design, the Open Embedded system, the system built everything from scratch. Building everything from scratch is a very good and attractive thing, because you eliminate the possibility of stall data that can cause problems. But building everything from the scratch gives us the problem of the build time. So so that's why we need a mechanism to work this, to work around, give a workaround of this, without we need to rebuild everything from scratch all the time. So this is what the state cache is for. What it does, in a general way, the state cache looks to the part of the system that can be avoided, avoid a rebuild. It verifies which piece of the system have changed and which have not changed, to do this, to trigger a build or not, or don't trigger a build, and check pieces of the software that were removed or replace it. Okay, in general, this is what the state cache does. When you do a bit bake, the state cache will always do this checking before starting a build to say, okay, we need to do a new rebuild, or we can use the cache for that. This is what state cache is gonna do. And the hash equivalent server, they have a similar purpose, but they treat another aspect of the caching mechanism. The hash equivalent server, to give an example, when you have a recipe, or you're working a C code project, and maybe you do a change that you delete a white space in your C code. This deletion will not, if you look at the output when you compile this project, this change will not modify the output. So this is like, we can define this as equivalent. So something with if you take a white for the C code, if you take a white space, you're not gonna see an impact in the end result. So the hash server will look for this kind of things, and will avoid to rebuild things. So they have a inner mechanism to do that. Another example of the hash equivalent server is when a good example is when you have a shared library and you do a update. So let's say you have a security fix. You will need to rebuild all the solution, the program that there is using this library, but some dependencies because the final project will be kind of the same. Some dependencies you don't need to propagate the build, the dependency chain. So the hash server, we're gonna manage this for us. By default, the hash equivalent server is enabled by default since Zeus or Yocto 3.0. And the purpose is to ensure speed and reproducibility of the build. Okay. So keeping that in mind, let's go to some practical uses here. First, I want to talk about the local setup using a sstate-cache. A very trivial one. So we have a build server, and let's say that this machine, we have enough resources, we have enough cores, like multiple cores, multiple threads, lots of RAM and storage. What you can do here, you can build your project and share the sstate-cache folders or the load folders and the cache with the hash server DB, which is the hash equivalent server. You can share this throughout multiple build, let's say build environments. Let's say we have a folder here, a build summit 1 with some configurations, some layers add to that, or maybe build 1 is will build for an x86 machine, and build 2 will build for ARM. We can share this sstate-cache throughout for those two build configurations. Okay. To do that, it's very simple. This is just an example. You can configure the ways more suitable for what you're doing. In our case here, I altered the download dir. I put the downloads folder in a folder before the top dir, and I configured the states dir for the sstate-cache in the same place, and also the persistent dir cache I put in this folder here for the hash equivalent server. All here is standard, so I leave by default. This is what Yocto give us by default, but I leave it here. We're gonna see some alteration in the next example, but this is just the default. Here's a simple BB layers I'm using to do this test, to do this build. Okay, and we're gonna see something like this in a file. Our folder organization, we're gonna see something like this. So I have a build 1, build 2, my cache downloads, my sstate-cache, and I created here. This is the way I see people doing, is create a folder to place my layers and another folder for the POC and the Yocto release and the default layers that come with Yocto. Notice that our idea here is to share the sstate-cache, downloads, and cache for this build configurations. Here we have an example. If you do this, it's very simple to see the effect of the cache, sstate-cache on your build. If you build everything from scratch, do a first build here without download folder and sstate-cache. I used a machine that has 16 threads, this CPU, 32 gigabytes of RAM. It took me something about 1 hour and 10 minutes to do a first build. Okay. And then next I removed my TMP folder, my output folder, and I tried to do, and I did another build, but this time I have the cache enabled that I get from the previous bitch bake. And you can see the time it took to generate an image was 1 minute. You can see that the decrease here is like something around 97%. 50%. So it's very considerable decrease. So this is very important to keep in mind. So maybe you're working, an example for this, maybe in your server, you're working in a project, you can, and then you need to start a new project, but it's the same Yocto release. You can share this cache and download folders in hash server. It will help you a lot in development and in the build time, next build time. So this comes as the default from Yocto Project and Open Embedded. But the idea here is to keep in mind that you can share it, you can configure it and move around those folders and reuse your cache to reduce your build times and testing and so on. So this was the simple test. I'm doing this all locally. I'm gonna see this scenario when you have a remote server. I think this is more interesting. So for this configuration, we have a build server, same as before, a good machine with a lot of cores, with lots of RAM and storage. And we're gonna do a build here. First, we're gonna build everything here in this build server, and we're gonna share the state cache, the download folders through an HP server to remote machines. And we're gonna share also the hash server. Hash server have an innate way of sharing this. The server. Gonna see how to do that. Here I'm placing machines, but keep in mind that this can be used easily, done in a cloud environment. So we're gonna see some values to do that in a cloud environment. Okay. So we have a build big server here with a lot of resources. We're gonna build everything from scratch here and share it. So how to do that in a very simple way. So first, the configuration for the server. Normally you don't need to do anything on the server for this to work. I'm just gonna change here my download dir and sstate-cache dir to this folder. I chose it to be so I can find it easily on my server. So top dir, a folder above the top dir, and I'll call it this server cache, and put the downloads, and here the state cache. I give here, I just noted here that you can also save your downloads, the tarball, if you remove this hash here, this comment here, you can preserve the tarballs of the source code that you downloaded. Okay, you can do that too as well if you like. And for the other guys, all the standards, all the standard thing of Yocto for BB layers. This is what I did for testing, those 3 layers. We're gonna see something like that when you generate a build. You're gonna see a folder, so a server cache. You're gonna see the download folder, then a state cache, and for that, to share this as a HTTP server, I'm gonna use a very simple way using a Python module. Okay, so in a production system, you can use it like using a HP server like Nginx or Apache server. You can also move this cache to another machine. Not necessarily you need to have this cache on your machine. You can move to a mirror machine too. But for our example, we're gonna do all in the same machine, the build machine. So this way I can create a simple server, okay, to share those folders. And moving to the remote machine, they're gonna use this mirror, okay? We're gonna set the local configuration of the remote machine. So for the download dir and state dir, we keep the default of Yocto. We don't change that. We're gonna talk a little bit what's gonna happen here. And for the configuration that we're going to do, sorry, I just moved a slide up ahead. But before I move into the remote, I passed this slide, which is how to start the hash equivalence server on the build server. So it's this command comes from the environment of the Pocky environment. You have this command, the bitbake hash server, and it will look for the hash db, hash server.db. And here I want to share it through, not by the default, which is a Unix socket, but I want to share it through a TCP socket. So I put here the port I want to use. And also I want to be my hash server to be a read-only, okay? And if you look in the documentation, you can also configure another upstream hash server to look to if you have this configuration. For now, we're just doing that, okay? And now finally to the remote machine. What we need to change there? We need to configure our source mirror URL. So here I'm gonna first configure for the sources. So I'm gonna configure the remote IP, the port I'm using, and the folder. So we download this path here and download file name path is the default way that Yocto does to find to identify the folders there. This is the standard. So for the state cache, you're gonna do the same thing. The remote machine, the port, the IP of the remote machine, the port and the folder where your state cache is. And finally, you're gonna configure the hash server upstream. You're gonna configure the remote server IP and the port that you did before in the server. So here. And the configuration, the layer configuration is the same one. So I'm gonna move forward to my remote machine. If I did everything right, when you do a bitbake, you're gonna see something like that. In the first summary, you're gonna see that you want to build this amount of package. You have 0 on local, and you find almost all the packages on the mirror. You miss 3, which are the specific one for the machine. So you can see just by this line, you can see that your mirrors are good, your configuration is okay, that you're gonna download the cache, the state cache in downloads and the hash server from your build server. Before going to the results, one thing to keep in mind is the bitbake, the logic behind the bitbake. So if bitbake will always create a local state cache download and hash server, even though you did a mirror, okay? And if when you do a bitbake, you don't find a package on the server, it will continue. We'll do the standard procedure. We'll download the package, build and create a state cache for it. Okay, and also bitbake will always prioritize the local cache before moving on to remote. And it only goes to remote if you can't find this cache locally. Okay. So in the final conclusion here, let's see what happens the build times let's take a remote machine here as very, very simple one. I used an i3 core, very old one with 4 threads and 12 gigabits of RAM. And I did a build here. So as you can see, as everybody, if you want use this type of machine to build, you can see a big time. So lots of time to build a simple image, a minimal image. Well, if I do the configuration I did before, configure my mirrors, and before doing any build here, I clean all my local state cache, output folder, and downloads, and did another build of the core image. You can see that we reduced our time to generate an image to 8 minutes. So again, if you compare, here's something around 97% on decreased time. So you can see even a modest machine, you can, with the proper configuration and sharing cache, you can do builds do builds that's if you very quickly, comparing to the builds if you do everything from scratch. But the downside or the catch here is that you need to prepare your cache, share it, have a build folder, we have everything in place to do this in this remote machines. Okay. And also, you just to keep a note here, you can share your state cache and download folders not only by HTTP. You can use, like, if you inherit this class on mirrors, you can see that you can use FTP, a S3 bucket, and also you can use NTF file system to share those folders through the network. And all this configuration I did with remote machine is very useful when you're using a cloud environment. So in this scenario, you can create machines very easily. So you don't need to create only a very big machine. Will cost you more to build all the time you work in this big machine. You can create a machine that have enough resources to trigger builds and generate cache on this machine, and then you can share the state cache and downloads that you did to others machines with constrained resources. So everyone who, if you have a development teams, not everybody needs to have like a very big machine to work to do testing. You can have a modest machine and prepare everything in advance in a larger machine. So if you look in your overall billing, doing that, you're gonna save. So you save money and time here if you do that. Okay, and also you can profit from faster builds. Okay, doing that. So just a summary here. I think we have just 1 minute, but it's gonna be very fast. Some strategies to keep your state cache update and some issues. So you can put your build server on a scheduler, like you can do it easily using cron tab or a CI process like Jenkins or buildbot. You have an example of buildbot here. You can use this time to build, so you schedule it weekly to build your cache, an example weekly. You can do this time to pull fixes from the upstream sources. So if you're working on a long-term supported release of Yocto, you can use this time to do that. And also it's very good to use word builds for caching to generate cache. So the words, if you haven't used before, word build will try to build all the recipes that are inside a layer. Okay, so you can prepare everything in advance, even if you're not going to use it in the final project. So just some considerations here. If you change the distro or the machine that you're building, you need to do that on your corresponding caching server. So to generate the cache for those, is normal to change the distro, and even if you have a cache, you're gonna see a lot of builds. So always pair your server with your remote machines. And if you're using older Yocto release, it's a good practice to to use a container strategy for that. So like for each version of the Yocto, some versions have some types of the dependencies, others don't have. So you can put this in a container, and you can separate the cache and download folders for each release. So the state cache doesn't work for each release of Yocto. You need a separate cache for each one, and also for the download folders. Well, for that, you can do a Docker container. Just remember to bind mount the state cache, the download, and TMP folder if you want to the host machine, so you can easily move around. And you can find an example for this in Docker Hub for the Yocto release that you are planning to do to keep and to maintain. So I think we're on time. So this is it.